You're supposed to say live.
Live.
Are we live? Hey, this is Phil McCaffrey, and welcome to 8:30 Prep. I'm sure we've got dozens and dozens of viewers watching tonight's fascinating ACT prep on trigonometry. So, as I've been talking since last Thursday, and we're going to go through all this week, is that there are 4 questions of trigonometry on the ACT. 2 of them have to do with SOHCAHTOA, and yesterday we did some harder SOHCAHTOAs. Of the other 2 questions, they come in 3 types, and that is the unit circle, which is today, trig functions, which is tomorrow, and then laws of sine and cosines, which is Thursday. So we got Tuesday, Wednesday, Thursday coming up. And my boy Gavin has asked me a question. Feel free, haha, I feel like a J joke there, Teo. Oh, say hello to Teo Hadfield. He is running the board for the first time all on his own.
I've been running the board.
You have been running the board.
First time completely out.
Now we don't have
by myself.
We don't have Damon. He's out delivering Wiggle whiskey for people because the state stores are closed, so you can get it. So don't forget, you can email me at phil@3rprep.com. I would be happy to answer questions live and post them on YouTube. So this is coming off of, Gavin, what's this, the December test? I just grabbed it real quickly while you were doing it. I think this is the December 2000. Damien's on. Hey, Damien. The December, which is the CO2 or something like that. If you email me, I've also posted how to steal secret tests off of the ACT. So this question says, if the positive integers, x and y, are relatively prime, the greatest common factor is 1, and 1/2 plus 1/3 times 1/4 divided by 1/5. You might have gotten this wrong because of the bad copy. A lot of times these are photocopies made into PDFs shared on the internet, and the ACT lately has been using the division sign. So that's probably, the December test. So let's write this down. 1/2 plus 1/3 times 1/4 divided by 1/5 is times 5/1. And so 3 times 4 is 12. And so this gives me 5/12. Let's turn 1/2 into 12 by multiplying 6 on the top and the bottom, and I get 6 plus 5 equals 11, and then the numerator is 12. They want to know x plus y. 11 plus 12 is 23. Yep, that's the right answer. The answer is A, 23. 11 and 12 are relatively prime. Their common factor is 1. So if you did this any other way, you could actually have done this in your handy dandy TI-84, which some student left behind. So if somebody's watching and left behind a beautiful calculator, that's yours. Let's see. 1/2, let's clear, let's go. That's 1 divided by 2 plus 1 divided by 3 times 1 divided by 4 divided by the quantity 1 divided by 5. Enter gives me 0.99961, and our favorite math frac button does give me 11/12. So the TI-84 does handle PEMDAS pretty well. I entered it in exactly as it is on there. It looks like this, entered in 1 divided by 2 plus 1 divided by 3 asterisk, which means multiplied, 1 divided by 4 divided by quantity 1 divided by 5, enter. So you could have gotten 11/12 with the math frac button, and we'll set this one right here because we got some math to do with the calculator at the end. Today we're going to talk about the unit circle, and trigonometry has in it the unit circle. This is a copy off of my playlist, the unit circle. The unit circle has a radius of 1, and so the 4 points of the map, it's 1, 0, 0, 1, -1, 0 is here, and 0, -1 is there. The unit circle doesn't come up that often. I only got a couple of questions tonight, But the important thing to know is that since the radius is 1, all the way around the unit circle is 2 pi at 360 degrees. At 180 degrees, it's half that way, or pi. And at 90 degrees, we are at pi over 2. At 270 degrees on the circle, going counterclockwise, we are at 3 pi over 2, or 1.5 pi. The important ones to know are 30, 60, and 30, 45, and 60, besides the 90s. And each one of them have a sine and a cosine as well as a distance. This distance around is measured in a unit called radians. And that is the arc length. It is an irrational number, pi, of course. And so we've got our unit circle 30 degrees. Let's put this out as 30 degrees, 45 degrees, and 60 degrees. And then the cosine and sine are the x and y coordinates of them. And they go like this. This is my favorite memory technique to use. And that is to start at the top at 60 and go 1, 2, 3, 1, 2, 3. Now all the 1s and 2s, all the 2s and 3s have square roots, and they're all divided by 2. So these are the x and y coordinates of each point. Then if we look at how far the arc length is at 30 degrees, 45 degrees, and 60 degrees, let's take 90 degrees as pi over 2, cut that in half, and we have 45 degrees as pi over 4. 90 degrees cut in into 1/3 is 30 degrees, and that gives me pi over 6. And then 60 degrees is double 30 degrees, and that gives me pi over 3. So this whole confusing mess is absolutely testable material. It's easy. It's a big part of trigonometry. Everybody has to fill out the unit circle in your trig class. So what do we also do? We have, and that is degrees and radians can both be positive and negative. Positive degrees are counterclockwise. Negative degrees are clockwise. So this is positive 90 degrees, where this clockwise is negative 90 degrees. Of course, they're never going to use negative 90. They're going to use something like 70 degrees. So they do like negative. They like going in the wrong direction, as you'll see on the question we're about to ask. All right. Another important thing is this table. This table you can Google. You should all have it for trigonometry class. If you haven't taken trigonometry class, you can still watch this, and there's enough YouTube videos on trigonometry to learn it. These are all the angles 0, 30, 45, 60, 90, 180, 270, 360 that I just put on the circle. The radians is the arc length. At 0 and 360, we've got 0 equals 2 pi all the way around. And then pi over 6, pi over 4, pi over 3, pi over 2, 180 is pi, 3 halves pi. You should know all of these, and you should be able to instantaneously recall them, as well as the 30, 60, 90 degrees. These are the points, the sines and cosines, that you will be asked if they come up, because they do. And the last thing about the unit circle is that sine squared plus cosine squared is equal to 1. I really wish they would write this backwards, because we always write x and y. Cosine is the x coordinate and sine is the y coordinate, and we always say xy. But nonetheless, in trigonometry, we say sine squared plus cosine squared. And what does that look like? It looks like a right triangle. So here's my cosine of an angle, and here's my sine of an angle, and here is my unit circle of 1. So this is the cosine, and this is the sine. What does it look like? the Pythagorean theorem. A squared plus b squared equals c plus equals c squared. In England, they don't use c. They use a, b, and z. A squared plus b squared, and they call z equals z squared, because of the three-dimensional Pythagorean theorem that if you have three dimensions like a box, a squared plus b squared plus c squared is equal to z squared, length times width times height, will give you a three-dimensional Pythagorean theorem. That's pretty fun, and that occasionally is tested. I've seen it every once in a while. But this is absolutely tested, as you're about to see. A squared plus b squared equals c squared. It's the distance formula. It's the Pythagorean theorem. It's the equation of a circle. It's the trig identity. All right, let's get on to some ACT problems, and this one is a 59. Notice that all of the unit circle ones that I'm going to throw are in the last 10, which are supposed to be the hardest of all. In trigonometry, an angle of negative 7/6 pi radians has the same sine and cosine as an angle which of the following degree measures. Let me toss in a circle. And if I toss in a circle and I draw my x and y axis, beautiful, and I start at 2 pi or 0, and I want to go 7/6 pi, I'm going to go all the way to here, because this is negative pi, this is negative 7/6 pi, which is equivalent to pi over 6 in terms of its sine. So where is it? It's 30 degrees. This is 30 degrees less than 180, or 150 degrees. Negative 7/6 pi is 150 degrees. If taken in the positive direction, this arc length is 150 degrees. A really good, really easy question, and it's a number 59. So those of you who are going for a really high score definitely should know your unit circle. All right, now here's a unit circle question that has nothing to do with a circle on it, but it says one of the following graphs in the standard xy coordinate plane is the graph of y is equal to sine squared plus cosine squared. Well, as we know as a trig identity, sine squared plus cosine squared is always equal to 1. That's the hypotenuse, the radius of the unit circle. And the graph of y is equal to 1 is answer choice H. All this asked you to identify was a horizontal line that y is equal to 1. This is a trig function. These are nothing to do with trigonometry. Well, I guess we could say they're cosines and sines. No, they're not anything. All right. And again, sine squared plus cosine squared. So if sine squared plus cosine squared is equal to 1, then 1 minus cosine squared equals sine squared, and 1 minus sine squared equals cosine squared. So for x such that x is between 0 and pi over 2, meaning that both cosine and sine are positive, the first quadrant, the expression the square root of 1 minus cosine squared over sine plus the square root of 1 minus x squared over cosine is equal to, well, 1 minus cosine squared is sine squared, and the square root of sine squared is sine. So this is sine over sine plus cosine over cosine, which is 1 plus 1, which equals 2. Lastly, I threw on a question that really isn't a unit circle, but it's a circle question, and it was a number 60, and it's really hard, and it has to do with angles, so I thought I'd have some fun with it, and that is an angle in the standard position. Okay, standard position meaning counterclockwise positive. In the standard xy coordinate plane has its vertex at the origin and its initial side on the positive x-axis. These things are all words used in trigonometry: vertex, origin, standard position. And so the angle is a standard position of 1,573. That means it's going around the circle more than 360 degrees, so it's kind of spiraling out like this. So how do we solve this? The first thing that I would do is see how many times 1,573 goes around a circle. So we're going to divide 1,573 by 360, and that's going to equal 4.36. So I divide this by 360, and it's greater than 4. It's 4.369, blah, blah, blah. To find out exactly the number of degrees, I'm going to take 360 times 4, and that gives me 1,440. 1,573 minus 1,440 is equal to 133. So 133 is equal to 1,573. So this wants to know which angle isn't equal to 1,573. All right, well, let's subtract 360 and go in the opposite direction, and that's negative 227. So I want 133, then I want negative 237. Let's go 360 degrees in both ways. Of 227, let's subtract 360, and we get 587. And from 133, let's add 360, and we get 493. So F, G, H, and J are all equal to 1,573. And, great test prep trick, if it is a number 60 and it's talking about 360 degrees and the number is 1,573, it's not going to be 573. So you could have guessed this one if you were running out of time, because these two numbers look too much alike. And that's Unit Circle on the ACT. Thank you for being a solo producer tonight, Teo. Don't forget the meme of the week. Monday, the meme of the week. Email me at phil@3rprep. A meme. What's that? You put it up there? You got it up there. Go on my Instagram. The Instagram is 3rprep, like this, because I've created two of them like an idiot old person that I am. 3rprep as an Instagram. We're going to do the meme of the week. There's one up there that Teo threw, so don't forget the meme of the week. And the question of the day, Gavin gets a Starbucks card for the question of the day. So I'll send that to your email account, Gav. All right, I'm Phil McCaffrey. We'll see you tomorrow night for Trig Functions.